let me share with you some issues of possible mutual interest regarding PPPM as a new kind of model of healthcare services and a novel avenue as a source of new tools to predict and to prevent chronic autoimmune disorders. Autoimmune diseases are a family of complex heterogeneous disorders with similar underlying mechanisms characterized by immune responses against self. Autoimmune diseases are the third leading cause of morbidity and mortality in the industrialized world. Most of the autoimmune diseases follow a chronic course that can be compared with a lengthy train ride. And a substantial need does exist for developing and validating a range of biomarkers of the newest generation that would address a number of important unmet clinical needs in the autoimmunity field. The journey mentioned begins based on pre-existing genetic equipment, followed by the onset of a cell-directed autoimmune response. And the earliest evidence that the journey has already begun is often found in the form of rising autoantibodies. The pace of the journey can be ascertained by the soluble mediators of autoimmunity found in the blood in the form of cytokines and antibodies against as well. If the train spirals out of control, a train wreck may follow. We may think of the autoimmune disease as the train wreck that follows the long journey of autoimmunity. It's a journey that can be timed in hours and in days as well, but more frequently requires weeks, months, or even years. Generally, it's only when the train wreck has occurred that the disease reaches the threshold of attention by the patient and the physician. Too often, diagnosis and therapy of an autoimmune disease is delayed only after irreversible damage has taken place. Look, just an illustration of autoimmune disease as applicable to humans, and tissues of the human body can be affected by autoimmune attack. It's just an illustration. The most potent genetic influence on susceptibility to autoimmunity is the major histocompatibility complex, HLA, which has been known for over 2 decades to affect susceptibility to a variety of autoimmune disorders. Different HLA alleles are linked to different autoimmune diseases. More precisely, autoimmunity results from disruption of different combinations of genes participating in the same immunological function, designated as immunological tolerance. Meanwhile, some susceptibility lots are shared by several autoimmune diseases, whereas others are most disease-specific or syndrome-specific. Nevertheless, due to the highly multifactorial nature of most autoimmune diseases, individual lots do not seem significant enough to be used as biomarkers for susceptibility or as diagnostic or predictive tools. In this sense, many exciting things are happening, including an expanded understanding of the genetic basis of human health and autoimmune disease through research, through years' efforts. Let me stress the link that may exert reliable control over morbidity, mortality, and disabling rates and significantly optimized the cost of treatment for those who had fallen ill whilst having either of the autoimmune disorders. The name of the link is predictive, preventive, and personalized medicine. It's just an illustration of the first summit on PPPM ever held at NIH in 24th. To achieve the practical implementation of PPPM concept, it's necessary to create a fundamentally new strategy based upon the pre-early, so-called subclinical recognition of biomarkers of hidden imbalances and defects long before the illness clinically manifests itself. This strategy would give a real opportunity to secure preventive measures whose personalization could have a significantly positive influence on demographics. It's just the illustration of the overall impacts to be assumed for the implementation of PPPM into the practice. PPPM, as thus the big change to forecast, to predict, and to prevent, is rooted in a big and new science to be rooted from the achievements of genomics, proteomics, metabolomics, and bioinformatics, which are being implemented into the daily practice to secure visualizing of lesion pathway that was previously unknown to clinicians. It's just the illustration of the overall omics platforms. Bioinformatics tools, aims, and objectives. In reality, the first omics platform, genomics, as a set of molecular tools to probe genome and to thus identify and to select genomic biomarkers, has allowed for identifying neurogenetic variations that affect health to form subclinical and predictive risks to be screened and unveiled, and then the subclinical pathology to be diagnosed, monitored, and terminated, if possible, to prevent tolerance breakage and thus the clinical illness. It's just an illustration of the genomic affiliated armamentarium used widely into the daily clinical practice. Over the last decade, genome-wide association studies, GWS, have identified many lots associated with late-onset autoimmune conditions, including type 1D, MS, multiple sclerosis, SLE, autoimmune myocarditis, and others. It's just an illustration of autoimmunity-related genomic biomarkers. Different lots of families. For this model, for this specific model, type 1D, about half of the total risk is genetically predisposed, and about half of the risk is in the HLA and other regions to be useful for gene-based predictive testing. The genetic map of multiple sclerosis. The location of gene and SNPs on the chromosome to be illustrated for your attention. The genetic map of MS. Gene products associated with systemic lupus erythematosus, SLE, that might affect the adaptive immune system. Gene products associated with RA, systemic autoimmune diseases affecting the adaptive wing. Well, genes can say a lot about an individual's predisposition to an autoimmune disorder, but cannot reveal what's happening in cells at the protein level. The latter would attribute to proteomics to identify individual proteins and their epitopes to be valuable for predictive diagnosing, and thus may eventually have a great impact on PPPM as itself. Meanwhile, a combination of the latter genomic and proteomic biomarkers are becoming of great significance to predict risks of the chronification. Please look at. And thus to predict risks of disabling, since chronic autoimmune diseases are preceded by a long subclinical symptom-free phase or a period of latency. It's just an illustration of the overall model of chronic disease of autoimmune origin. Subclinical cryptic latency and clinical illness correlate with stages of subclinical and full-term autoaggression. It's a natural history of type 1D, which would suit for the latter model. In reality, proteomics per se is the continuation of functional genomics, and at the same time a prologue or an invitation to shake hands to metabolomics. Look, the latter, metabolomics, illustrate the functional state of the cell at the level of its metabolism, on a real-time basis, requiring the use of the term metabolome, demonstrating a set of metabolomic pathways in the cell at a given time point. Tissue-derived information we would accumulate from the sources, including molecular architectonics and profiling of the autoimmune disorder at its clinical and subclinical stages. Laboratory and instrumental armamentarium, predictive testing, and susceptibility and resistance testing might be combined with individual medical records, family history, data from imaging, instrumental and laboratory tests to develop personalized and preventive treatments. But in this sense, how is the whole data bank or data sets provided by omics technologies could be comprehended, processed, and be implemented into the real practice? It's bioinformatics. To suit the goal by applying mathematical modeling techniques to thus secure constructing and maintaining unified biobanks and data sets necessary for personal health monitoring, including e-health monitoring based on principles of genotyping and phenotyping. As a result, the patient becomes a data carrier whilst learning about possible risk of a disease, and the physician can reasonably select a kind of preventive and personalized protocol rooting from the predictive assays made. It's just an illustration of the overall approach mentioned. By integrating bioinformatics and clinical healthcare informatics, both offers unique infrastructure, tools, techniques, and applications to bridge those areas. This facilitates the sharing of data and information across diverse disciplines, multidisciplines, and professional sectors to unveil the clinical case illustrating the autoimmune conditions. It's just an illustration. Individuals selected in the first genotypic affiliated stage undergo the second stage, which uses a panel of phenotypic biomarkers whilst monitoring every potential patient, every person at risk predisposed to the autoimmune disease and/or persons at subclinical stages of the disorder. Biobanks would thus supplement the proper information and data sets about patients' proteomic, genomic, and metabolomic profiles to be used to tailor, namely tailor, medical care due to the individual needs and personalized scenarios. An understanding of the factors underlying the burden of a disorder and later on of the clinical illness or full-term clinical manifestations would provide policymakers, healthcare providers, and administrators and medical educators with an opportunity to guide preventive initiatives at both individual and community-related levels. Look at PPPM will require the integration of different kinds of information into the consolidated pipeline. And you might understand that bioinformatics will be crucial in translating those data into useful applications leading to improved diagnosis, prediction, prognostication, and thus treatment. So our viewpoint would support the contributions of genomic and proteomic approaches in developing a preventive and personalized approach to manage chronic autoimmune disease and to thus monitor the patients and even persons at risks. PPPM thus use diagnostic and predictive tests of newer generations based on biomarkers to individually determine the health conditions a person is predisposed to the autoimmune condition and to reveal biomarkers of the probable or the already existing pathological processes, and thus to select the proper or specific targets. PPPM-oriented survey we are working on now should be based on biomarkers and algorithms to differ essentially from those employed in canonical clinical strategies, namely, first, algorithms for predictive and subclinical diagnostics on one hand, and algorithms for preventive treatment on the other one. From phenomenon, some steps forward to reach genome to phenome. In the era of personalized medicine, there is increased interest in the incorporation of individual biomarkers in risk score algorithms in order to improve autoimmune disorders related risk stratification, followed by prompt initiation of preventive measures whilst evaluated the predictive and prognostic value of currently used biomarkers like canonical autoantibodies, cytokines, specific proteins, and ligands, as well as promising future-affiliated biomarkers like non-coding RNA, silencing sequences, pathway-associated biomarkers, and the newest one, combinatorial biomarkers, as the latest one. Most of the latter are directly associated with development of chronic autoimmune disorders. So we would need absolute proofs to confirm clinical applications of the biomarkers mentioned, evaluating not only their diagnostic and prognostic values, but also their integrability into routine practice. Also, a single biomarker is a tangible entity that can be easily understood. Aggregate measures comprised of multiple genes are also informative as the combinatorial biomarkers. The simultaneous addition of combinatorial biomarkers of autoimmune disorders to the score index panel substantially improves the risk stratification for death and disabling. And clinical potential may be evaluated, assessed by asking three fundamental questions. Look, can the clinician measure the biomarker as applicable to chronic autoimmune diseases? Does it add new information? Does it help the clinician to manage the disease? The incorporation of the multiplex but consolidated biomarker-based panels mentioned into clinical practice for the prediction of death and disability, causes could be accomplished quickly, since the measurement of those biomarkers is already well established for diagnostic use. And there is urgent clinical need to identify predictive combinatorial biomarkers for subclinical PFAS, post-infectious autoimmune syndrome, to allow preventive treatment strategies to be instituted early in the disease running. Look, it's just a representation of PFAS. We have made it as an outcome of 7 years studies. A crucial role in formation of PFAS and progression to develop clinical illness is played by inborn, is the first place HLA-associated predisposition coupled with impaired immune responsiveness of the human body, invaded and having had signs of dysbiosis. Since recent data has stressed the importance of the endomicrobiota in human homeostasis. In this sense, then, how the endomicrobiota influences host immune responses to provoke autoaggression. When microbes are critical for development of PFAS, several mechanisms can be discriminated. Which one, in specific terms, is just a look around. I'm not going to get into detail. As you know, antimicrobial immunity is based on sequential reactivity of the innate and adaptive wings of the system. And the final version of PFAS is controlled by the coordinated functioning of innate and adaptive arms on one hand, and the interaction of the arms with endomicrobiota on the other one. As you see, the host genetics defines the interactions with the endomicrobiota, and the outcome of those interactions affects the autoimmunity risks package. Indeed, autoaggression provoked by insufficient coordination between two immune arms and hyperreactivity of the adaptive one is a dominant feature of PFAS to serve as a combinatorial biomarker to monitor PFAS and then the PFAS-dependent autoimmune disorder. Its unique feature is a broad repertoire of autoantibodies responsible for multi-seropositivity and thus to autoimmune inflammation biomarkers. For example, at the bottom. Several examples. Autoimmune myocarditis usually develops in genetically predisposed individuals infected with CVB3 or related viruses to represent typical manifestations of molecular mimicry. It's just initiation and progression of autoimmune myocarditis from acute infection or subacute to chronic or presumably autoimmune origins. Okay. It's just an illustration. PPPM is thus a model of healthcare services being tailored to the individual and dictates a construction of PPPM-based algorithm to diagnose, to predict, and to prevent autoimmune conditions in time. This approach should be based on postulates which will change the incarnate culture and social mentality and to avoid misunderstanding between research, academic, and clinical communities. Thank you so much for the introductory, not brief, speech.
Thank you very much.